So if we are focusing on each of these being the base shape of a rectangular prism, so we're pretending these are all going to be prisms, and they're all going to come up to a certain height, you know, however tall I'm going to have it going, but their bases are not going to change, right? So maybe we're going to have 5 of these C's stacked on each other versus 5 of the B's stacked on each other versus 5 A's stacked on each other. So what I'm wanting to know, if they're all going to have the same amount of stacking to build a height, to build it three-dimensionally, then which one of these is going to have the greatest volume and which one's going to have the least volume, and how do you know? Like, explain your thoughts. Io. How do you know?
Because volume is big times height, so the longer
Well, volume's not base times height. Area is the base times height, or the length times the width, right? And you're correct, okay? But if we're all focusing on having the same height, they're all having one measurement that is going to be identical, then you're looking at the other measurements to see which one's going to be bigger. How many square units is C? 12, right? There's 12 squares here. C is going to be equal to 12. How many square units is B? 4. How many square units is A? 3. Okay, so C happens to have more square area, square footage, than B and A. So if they're going to have the same height, then you're focusing on which one has a larger area to begin with. So since C has a larger area, it's going to have a larger volume. Again, only because the heights are the same. Now, if the heights were different, that wouldn't be necessarily the case, okay? And then A has the smaller, or the smallest area, so it's going to have the smallest volume. Again, only because they're all going to have the exact same heights. Because their heights are going to be identical, then the only thing that's going to affect the volume is the area of that base shape. Now, if I said that the volume is going to stay the same, so they're all going to have identical volumes of 24 units. So if I said the volume was going to be 24 units, then how tall would C have to get? If I said the volume is going to be 24, then what would the height have to be in order to change 12 to a 24? Isaiah? 2, right? It would just have to be 2 times for the height. But what about for B? How tall would B have to be? 6. How tall would A have to be? 8. So A would wind up having a taller height, even though they all have the same volume. They all have a volume of 24. A would have a taller height because it has to compensate for the fact that it has a smaller area. It doesn't have much spread, so that means it has to go up taller or higher than the rest of the buildings in order for it to have the exact same volume. It has to make up for that loss somehow. Okay, so A is the smallest area, so it needs the tallest height. Because it's the smallest area, it's going to need to have the tallest height. And then in the reverse, C is the largest area, so it needs the smallest height. Okay, so the thing that you need to make sure you understand, what's really important when doing volume, what matters the most is the area of your base shape and the height of the prism, the height of the overall prism. So this should kind of look familiar because when we talked about surface area, we talked about capital B and capital H. Remember, we said that capital B was going to stand for your base shape area, or the area of the base. And that capital H was going to represent the height that connects those two bases together. Because remember, if we're talking about a prism, we're talking about two identical base shapes that are connected together by a single measurement called height. So it's the height that connects the two bases. Okay, so when we're looking at a rectangular prism, it doesn't really matter which rectangle we choose to be our base for the rectangle. But a lot of people tend to like to focus on height as it's going up and down. I don't want you to get too used to that though, because who knows how tall they are? Anybody know how their height? Isaac, how tall are you? 5'4". Okay, so when he's standing up, he's 5'4". But what if he's laying down? Is he still 5'4"? Excuse me? If he's laying down, is he still 5'4"? Yes, his height doesn't change. He's still 5'4", whether he's laying down or he's standing up. It does not matter whether the shape is standing upright or laying down. So what I mean by, right now, triangular prism here, the height of this triangular prism is 15, even though the triangular prism is laying down. It's not standing upright. But the height is what connects your base to your base. So it doesn't always have to be the value that goes from top to bottom. That's not always what the height is of a prism. A prism can be standing upright or it could be laying down. The height doesn't change just because you're standing upright or laying down. Height is still your height. So for here, I could say that my height is this rectangle right here, or I could say it's the rectangle that's on the bottom. It doesn't matter as long as I choose one rectangle as the base, and then the other measurement is the height that connects the rectangles together. So I know I have a rectangle down here at the bottom. I have an identical rectangle here at the top. If I let those be my bases, then that's perfectly fine. And again, to find the area of a rectangle, you have to do base times height. The base of this rectangle happens to be 12, and the height of that rectangle happens to be 5. So I would be doing 12 times 5, which is going to wind up giving me 60. And then I'm going to multiply that by the height of the overall prism. That height is what connects my prism from one top to the bottom, or from one base measure to the other base measure. And in this case, that's going to be my 3. So then when I multiply those together, that gives me my volume. Volume is going to be equal to 180, and that is inches cubed. Volume is always a cubic measurement. Volume's always going to be a cubic measurement. Okay, let's look at it again. We're just taking the area of the base shape and we're going to multiply it by the height of the prism. So it doesn't matter that these ones have fractional values. It's still the exact same concept, that you're identifying your base. So I'm going to say that my base is located right here, where I'm using 2 2/3 and 1 1/3 as my two measurements for my rectangle. And then the measurement that's going to connect those two identical rectangles together is going to be this 1 5/6. That's going to be the height of the overall prism. So I would do 2 2/3 times 1 1/3. That's going to come out to 3 5/9. Then we're just going to multiply that by the overall height, the 1 5/6. Okay, and that will give you your volume. So our volume in this case is 6 14/27, and that is cubic feet. So rectangular prisms are typically your easiest measurements to do, your easiest volumes to do, because a lot of people like to think of it as, well, I'm just multiplying everything together. I don't want you to always think of it that way, though, because sometimes they might give you extra measurements on here, and then you're like, well, wait, which ones am I multiplying? Same thing with your triangular prism. You're not multiplying every single value you see together. Sometimes they give you measurements of sides that you don't really need. So you want to make sure that you understand you're finding the area of one base rectangle, and then you're multiplying it by the height that connects those two identical bases together. Okay, when you're done, go ahead and flip it on over to the back. So we're looking at these triangular prisms now. Again, all you're going to do is find the area of your base shape. But it happens to be this time your base shape is a triangle. So we're trying to find the area of our triangle. Now, the area of a triangle is taking the base of the triangle, the little height of the triangle, and then dividing it by 2. Okay, so looking at the triangle, we just need the base and the height of that triangle. So here's our base of our triangle. Here's the height of the triangle. That means that these two side measurements we don't need. Those side measurements are only there if you were going to be doing surface area, but for volume, you don't need these other side measurements. You just need the base of it and the height of it. And keep in mind, again, the base and the height are the same from triangle to triangle in this case. So we have our little base and then our little height of 4. So we're going to be doing 6 times 4 and then dividing that by 2. 6 times 4 divided by 2 is going to come out to 12. Okay, then we're going to find the height. Again, the height is what connects your triangles together. The measurement that connects one corner of one triangle to the exact same corner on the other triangle. So if I start at this corner, then I have to end at this corner. So that measurement is going to be 15. And guys, it is 15 universally throughout the entire shape. This measurement is also 15. The measurement directly across here is also going to be 15. It's the same height all the way from one triangle to the next. So this is our overall height. So we're going to multiply 12 times 15, and that's going to give us our volume. So volume in this case is going to be equal to 180 centimeters cubed. 180 centimeters cubed. Okay, I want you guys to go ahead and do problem 4 on your own. So for problem number 4, who can tell me what did they get for the volume of that triangular prism? Aya, what'd you get?
2,230.
Not quite,
Oh, wait.
because you forgot to do something. Remember, area of a triangle is base times height divided by 2. Did you remember to divide it by 2?
I forgot.
Okay.
1,620.
1,620. Good. You want to be careful about that. Okay. Now, keep in mind when it's a right triangle, whenever you see that right angle, guys, the right angle forms the base and the height of your right triangle. So the base of your triangle and the height of your triangle are going to form those right angles inside of a triangular prism. Okay, so again, for a problem like this one, let me go ahead and divide this off. For a problem like this, you're finding the area of your base shape by multiplying 12 times the 9, that's the base and the height of the triangle, and then dividing that by 2. And 12 times 9 is going to give you 108, and then when you divide it by 2, you're going to get 54. Okay, and then the height is what's going to connect your two triangles together. So that's going to be the 30. So we're multiplying 54 by 30, and that's going to give us our volume. So volume in this case is going to be equal to 1,620, and that is inches cubed. Okay, and again, it's the same exact concept when we're dealing with a cylinder. Again, you find the area of the base shape and multiply it by the height of the prism. In this case, our base shape happens to be a circle. So when we're dealing with a circle, our formula is r squared times pi. So we need to know what the radius is of that circle, and then we can multiply it by pi, 3.14. In this case, what is the radius going to be? 4, right? The radius is going to be the 4. So we have a radius that is equal to 4, and then we have an overall height of 10. So we're going to do 4 squared times 3.14. 4 squared is 16 times 3.14. You're going to get 50.24. And then you're going to multiply it by the overall height, which was 10. So you get a volume of 502.4, and that is meters cubed. Go ahead and do problem 6 on your own. Do problem 6 quickly. So for this problem, again, we need to know what the radius is going to be. Did they give us the radius in this problem? No, they gave us the diameter, right? That 12 is going to represent the diameter. So what's the radius going to be? 6, right? The radius is going to be half of the diameter. So the radius in this case is going to be equal to 6. So then when we substitute it into our formula, the area of our base shape, we're going to do 6 squared and multiply it by 3.14. 6 squared is 36 times 3.14. That's going to give us 113.04. And then we're going to multiply that by the overall height, which in this case happens to be a 6 as well. Okay, and that gives us our volume. So our volume is going to be 678.24, and that is centimeters cubed. All right, so your assignment for today, you have a scavenger hunt that you're going to be doing with your table mates. So how the scavenger hunt is going to work, you have several different cards here. You're not going to cut the cards out. You're not going to write on this as well. You're going to leave it completely empty. What you're going to do is on your papers, each of you is going to get an individual paper. You're going to put your name at the top. Over here in the corner, every single person is going to start with the letter N, the card N. What card are you starting with? N. So here in the corner, you're going to put the letter N, and then you're going to show your work. You must show your work in order to receive the credit. So you all are doing this together. You cannot do a divide and conquer because you're following the order. Once you work this problem out, it's going to lead you to the answer on a different card. So once you find your answer, so let's say that this answer was 240. Then the next card you would write is E, and this is where you're going to work out problem E on, and then it'll lead you to the next problem, By the time you finish with problem 15, problem 15's answer should be 5. So if you work out these problems and you get 5 as an answer before you've gotten to problem 15, then you've made a mistake somewhere along the line. All of these should be connecting you to the correct order. This is to be completed first. You are working together. Make sure everybody at your table understands how to do every problem. You are not able to just go off on your own, okay? Because you get one set per table. Once you are done with that, then there is another one of those battery drain problems that we did a while ago. Let me open it up real quick. It is on, obviously, volume. So when you open it up, it's like a kind of like a hangman type thing. You click on the arrow here to pick one of the questions. So like if I want question number 12, I'd click on number 12, and then I'd find the area, or sorry, the volume of that shape, and then put my answer down here for problem 12. If it comes up green in my battery, then it means that I got it correct. If it comes up red, then it means I got it wrong for the battery. Once you have finished all the problems, you get a certain amount of chances to be able to guess what the correct answer is for your hangman. So you want to make sure that you're trying as hard as you can. You can work with each other on this as well, as long as you finish the scavenger hunt first. If you don't finish the scavenger hunt before class is over, then this battery drain becomes your homework tonight, okay? But all of it needs to be completed before class time tomorrow. Any questions? Okay, let's go and get started.